Welcome to this review of the new features in Autodesk Inventor 2019. We've picked what we think will be the highlights of this new release, and this video aims to provide some insight, hopefully, on how you can maximize the usage of these new tools. Here's the agenda we'll be covering. For parts, we'll be focusing on the new variable Helical Curve tool and also the updated hole feature tool. And for assemblies, Autodesk have put a lot of attention into the constraints. We'll be covering those in detail. But we think the main ticket update for Inventor 2019 is some iLogic additions, and we've put together 5 examples that are possible with the new capabilities of the iLogic tools to hopefully stimulate your imagination. Hope you enjoy it. Let's look at the new Fillet tool in Inventor 2019. You wouldn't think it would need improving, but there was more than 300 requests for this one on the Inventor Idea Station, and the way I like to think of it is either adding a weld fillet or adding clearance for a weld fillet. Let me show you what I mean. So if I double click on this part here, if I start the Fillet tool, I've got a sneaky option down here to do an inverted fillet. So the normal arc that a fillet would take is reversed using this tool. So let's pick an edge here, and instead of the usual arc, I've got extra material added. That's the normal fillet, and this is the new inverted fillet. So it's almost as if it's being welded there. It's adding a representative fillet for a weld. Pretty handy, I think. You'll know if you're one of the users who's requested this. So let's apply that one. And the inverse of that, if you've got an external edge here, if I hit return here and edit this part here, let's get rid of the existing chamfer on there, if I can find it. Let's delete that, and let's create a new fillet here on here. So that's a standard fillet, but if I do the new inverted fillet, that's almost giving me clearance for as if this part is mated to a part with a weld here. That would give me a nice clearance to the weld, even if the weld is a bit proud of 45 degrees. Okay, so pretty handy. A couple of things to bear in mind for this tool. If I show you another part here, you can still use the fillet all edges. So if I show you this part here, let's hit fillet. We can still do our all fillets here, or all rounds here, and if I switch these types to inverted and inverted here, you'll see the kind of result we get. I'm going to say OK. Probably some of them won't be able to achieve, but we still get our option to accept the successful ones. So I'll say OK, and look at the result that we get here. It's done that clearance as if this is going to be welded all the way around. So you can get some really interesting effects, and to sweep these cuts around using a traditional method would take a pretty long time to achieve. Another thing to bear in mind is the setbacks. So if I hit setbacks here, we can choose a particular vertex and we can choose a different kind of setback on it. So let's delete this fillet, and I'll show you a bit more cleanly how this works. So let's start the inverted fillet tool. Let's pick our edges here, and that's the normal intersection we'll get between 3 edges. But if we choose our setbacks here, and if I choose a vertex, then I can get a different setback there and another different one, ticking this minimal box. So you can have a play around with that, even adjust the setback distances here, but it's probably more a case of trial and error to get the result that you're after. Okay, very last thing for this fillet tool, if you're working in an existing assembly that's got a fillet, or an existing part I should say, that's got a fillet, and you try and edit the fillet here, I think even with a migrated part you won't get the option to do the inverted fillet, so you'd have to delete the existing fillet on a 2018 part and recreate it with a new fillet tool in order to be able to invert it if that scenario does actually come up. Let's take a look at the variable Helical Curve in Inventor 2019. It allows us to create geometry like we see in front of us here. This spline, helical spline here, was created with a single command, whereas previously it would be quite time consuming to create that with intersections and so on and so forth. And we actually create this helical spline in a table format just to input each of the different sections. And for this example here, I'm going to delete the pre-made one that I created there, and I want to create this sweep, this helical spline, across this exact geometry rather than just typing in random numbers into the table, to show you how this would work in a more real project. Okay, so let's just delete that sketch as well. So we start the 3D sketch command, and we use the helical curve tool here. This one's new, a variable helical curve, and here's the table that we can input the data in. But first let's position the start and end point of the helical curve. So the start point's here. Let's just put the end point on there for now, and you see we initially get just an option to put any old size in. Let's just drop this down here, and then we're starting to create our table here. Let me just resize this to make it as easy as possible to see what's going on. So rather than just typing in random numbers, as I said, how do I get this helical curve to follow the shape of this revolution I've already created? Well, you get several ways of defining the shape of the coil, and it really depends on which sketch, if any, you want to use to define the shape. The really nice thing about this is you can switch it later on when you're in the middle of creating your table, and all the numbers will update, or in fact all the editable numbers will update, and you'll be able to edit different numbers. It's a really nice method. So if I have sketched my revolution with specific heights in there, I definitely want one of these height ones. Don't particularly care how many times it spins around, I just want a certain pitch for the coil. So I'm going to say pitch and height, and this is your first row, so the height is always going to be 0, and let's just say the pitch I want to initially be, let's just say it's 40 millimeters. I can't type in revolutions because I'm not defining by revolutions, but I can type in a diameter. Now I don't want to have to remember what the diameter is at this stage, so what I can do is I can hit this arrow here, and I can either say list parameters or I can say show dimensions. What I've actually done here is I have actually renamed some of the parameters in my sketch to dia 1, 2, 3 here, but if I hadn't done that, if I hadn't realized I needed to do that beforehand, what I can simply do is say show dimensions here, and then click on the feature that I want to show the dimensions of, which is this one here, and then I can say, aha, I want that diameter to be this one, because that's coming from my revolution sketch there. You see, so if I pick that, I've happened to name it dia 1, so I could pick it from the list just as easily. And that's fine. I can't edit the height because that's my initial stage here, represented by this dot. But this second option here, let's just say I want the pitch to be, let's say, the same, 40 millimeters. I can't enter revolutions because I am doing by pitch and height, but I can change it here. If I wanted to, I could say, actually, I want to enter revolutions here. So then I could type in a certain number of revolutions, but I can't edit the pitch anymore. So you've got to be careful with that. So I'm going to leave it on pitch and height. And my diameter here for the second point here is still going to be dia 1, but if I don't want to type it in, I can just say show dimensions, pick that, and choose the dimension that I want that to be, and you see this locked down there nicely. And what height, what length along the shaft that do I want that to be? Well, I can show dimensions for that as well. So I can right click, show dimensions, pick this, and there we go. There's the length of my first stage. So see, that dot represents that line, that dot represents that line. Nice and easy. I've named that parameter as well, by the way. So I'm going to click to add, and I can simply just go and repeat myself. Let's say I want to increase the pitch for this section. Diameter here is, if I show dimensions, diameter for the next stage is that one, isn't it? So if I pick that one, it's diameter 2, my height, right click, show dimensions, the length this is along the shaft, length 2. Okay, and click to add again. So I can just repeat myself. There's stage 3 that I just added. I'll make the pitch still 60 here, diameter 2 still, but a new height. Let's right click, show dimensions here for this one, and length 3. Okay, so you can see this height if you just check the next one that I'm going to put in. Let's just make the pitch slightly different here. Diameter here for my next stage is diameter here is 60, and the length, just if I show you this, if I show dimensions, you see all these lengths are from the start, right? So they're not consecutive, they're all cumulative lengths. If I try to type in a length that's less than length 3 here, then I'll get a problem. So if I type in 100, it says, oh, it's got to be more than length 3, because otherwise the shaft's going back on itself. Okay, so cumulative numbers here. So I can pick length, is that right? Length, no, I want length 4, so I want this one here. Yep, and click to add. Let's just make the pitch slightly smaller here. Diameter here can stay the same. Right click, show dimensions here, and I just want a slightly different pitch, so I'm keeping the diameter the same here, but I'm going to click to add, and the end pitch I want is, let's say, slightly longer. Okay, so in fact I want a consistent outfeed, for instance, at 40 pitch here, so diameter can stay the same, and I've got my final length. Right click, show dimensions, final length in there. Okay, so you can see that this helical coil follows the shape that I've defined with my revolution sketch really nicely, and it's parametric, right? So if I make any changes to the original sketch, this helical coil will update. Another thing that's really nice in here is obviously I can flip the direction of rotation, but I can change this definition as I'm going. So if I decide at this point, actually I don't care too much about the pitches, I want to have specific numbers of revolutions involved for each of these stages of the coil, what I can do is change to revolution and height now. And then see all these revolutions are available for edit. So that one's not quite 4, so I can change that one. I can make that one 5, 6, 7, because I want nice clean round numbers for the revolution. And you see there's some certain limits here, and this will update the pitch for me, so the pitch may not be round numbers anymore because I've chosen to define it by revolution instead. Okay, so let's say OK here, and we've got OK, and we've got this helical curve following the geometry. If we've got 2 sharp changes here, then we'll see some overlap, and we could use this helical curve now to define a sweep. So that's really nice and easy to do. I could pick there, and I can just sketch on this plane and sweep along a circle, for instance. Let's just sketch a circle of 30 millimeters and sweep that along. Of course, the plane that I sketched this circle in is important, so I'd need to probably adjust the plane that I've sketched it in. And there we go. And I can cut that away, for instance. If you want any more advanced options like controlling the angle of the sweep as it goes along, for instance, you'd need to create a guide surface, perhaps copy and paste your helical curve, which it is possible to do. You can right click, copy and paste a 3D sketch in order to create multiple ones of those. And as I said before, the nice thing about this now is I could go into an iLogic form, or I could go into just my normal parameters of the model, and I can change and update a particular value, and the sweep will also update to suit. And just one last thing, I have to say this, guys, same with any other geometry you sketch in Inventor, make sure it's fully constrained. Of course we have to fully constrain our helical curve here. If I go into this 3D sketch, it's a funny color because it is not fully constrained, so you're going to create a whole world of pain if you leave geometry free like this. So I would do things like put a coincident constraint between there and the origin of my part, which sorts that one out, and then I would probably put a parallel constraint. So I'll make which axis do I want it to be aligned with? Is that the x-axis? I'll say I want this line to be parallel with the x-axis. Yep, and now it can't be moved. The last thing I'd need to do is to specify the start point, because you see this can still rotate. So I would need to add a coincident constraint, for instance, between this point and a plane to lock the rotation. I'd do something like right click and make a plane visible here, use a coincident constraint between, say, the start point here and the plane, and you see that changes the color of the helix in the sketch to indicate that it is fully constrained, which of course is not new in Inventor 2019. You knew that already, but I just couldn't help myself. Okay, let's take a look at some better control that we have of transparency in images in sketches, perhaps with a view to creating a decal and a render of the image in the sketch. I'm in Inventor 2018 here, and I'll show you the problem that we could have with images and sketches in the previous version 2018. So I'm going to sketch, do a really tasteful logo on the footboard of this bed here. So let's left click to create a sketch. Let's insert an image, and I'm going to pick an Exotech logo which has which has an alpha layer on it, and it also just has a white background here, and that's fine. It drops down as expected, but I can right click and change the properties of the image here, and there's only one option for transparency. It's use a mask. Well, what is a mask? Let's try. Let's say OK. Okay. Well, it's turned everything that was white transparent, but that's actually not. There's a bit more happening under the bonnet there than expected, which caused people some problems. If I add a second image here, which appears to be exactly the same as the first, unless you're looking too closely, but there's a important minor difference here. Let's add that image in. I want to make that transparent, so I'm going to right click and choose properties, and I'm going to use the mask and say OK, and it does not go transparent. Well, what is the mask? Well, the way Inventor used to work is it used to say find the bottom right hand pixel, which in this case was down here and it was red, and make that everything that's the same color as that pixel there transparent. So basically it determined the color of the mask for you, whereas really you want to determine the color of the mask and say, no, actually I want this color to be transparent, same as you could do in PowerPoint or Photoshop or anything like that. So that was one problem. The second problem is images actually, if you've produced them in Photoshop or a proper image editing tool, they can have an alpha channel on them, or an alpha layer. And there was no way to reflect that in the Inventor sketch either. So let's finish up in Inventor 2018. Let's head into Inventor 2019, and let's see how it's different. So I'm going to go and do the same image on this part here. Let's start a sketch, and let's insert an image. So let's choose the first logo initially, and let's drop that down. And we get the same options with a right click on the image here, properties, but we get extra stuff. We can either say not transparent, we can use a mask, but we get to determine what the color of the mask is, which is really handy. So if I say set chroma key, I can say I want it to be white and say OK, and that will have the desired effect, which is great. But let's have a look at another option it's added in there. We couldn't do this at all before. We couldn't use an image alpha as well. So let's say OK, and you see we get a slightly different result, because this is the alpha layer that is coming through from Photoshop, or the program that created this logo. And so you see a very subtle difference. I might want that alpha layer to be reflected in the Inventor part. And let's just delete that image. Let's try adding the one that had the red pixel in the bottom right hand corner, which was causing a problem before. Let's drag this up here. You see that would have made only the bottom corner transparent before. Let's right click on the image, properties, use mask, set chroma key. You see it's said red is the default because that's the pixel in the bottom right, but I say no, actually I want a white mask here. Okay, and I can finish this sketch. And now just for a little more background information, if I wanted to render this now, that won't of course come up unless I turn it into a decal. So I'd have to go to 3D model. obviously going to need to go into the part file first. There's a schoolboy error. And start the decal tool, choose the image, choose the face and say OK. That's created a decal. Now if I return to the top level assembly, and if I want to render this, I can go to realistic visual style and I can hit ray tracing and I'll get a render of that decal. Fantastic. Let's look at one of the improvements to the direct editing tool. For my money, this is one of the finest tools in the Inventor arsenal already, but there was an issue in 2018, or a scenario where you had to do a bit of a workaround to get the result that you want. I'm here in Inventor 2018, and if I try and do a direct edit to move, I want to shrink or grow this slot here. So let me select this face. If I try and move this face, then the whole slot moves. I can't resize the slot in that way. So what I would have had to have done is to use the split tool, split the part along the middle, split the solid, say OK, then use the direct editing tool, pick half of the slot, resize that half, and then maybe pick the other half and resize that half as well, and then combine the two solids again afterwards with the combine tool, which works fine, but it's a bit long-winded. So if we flip over to Inventor 2019, that workaround is no longer required. I can start the direct editing tool, and you'll see in both the move and the rotate options I've got this handy tick box for automatic blending. So you're going to forget whether you need to tick it or not. I always do, but you can try both ways and you'll probably get the result that you want. So if I pick this slot here, with automatic blending turned on, I get the old behavior in this case. Let's just type in 0. With automatic blending turned off, I get the behavior I'm after, which is that. So I can hit plus, pick this one. With automatic blending still off, I can resize both of those slots, which is great. If I want to, let's try rotating this one over here. Again, not quite sure whether I need to tick it or not, and I could try and tell you, but you'll forget it as well. So you just try both options basically. If I pick this one here and I want to rotate the whole lot, obviously I could pick all the faces, but let's just try a rotate here. And if I rotate this, then with automatic blending off, I don't get any result. With automatic blending on, it will automatically select all the adjacent faces for me, which could be quite handy to avoid having to pick lots of fiddly little faces to get the result that you're after. I think this is a great improvement. If you're using sheet metal in Inventor 2019, you might be interested to learn of the new corner relief for tube end intersections. If I go to the flat pattern here, this is an arc weld corner relief. If I go to the corner settings here, let's make the gap a bit bigger so that we can actually see what's going on here. If I just save that. So this is an arc weld corner. You now have a new option to do a laser weld corner, which is pretty similar but just gives you a tangent arc here. So if I close that and cancel that and head back to the folded part, this will also reflect on the folded part and you get a bit of a cleaner gap here. Let's just make that mitre gap a bit smaller, and that will stay even if you've got a small gap there, you'll get a nice arc here on the flat pattern and the folded part. Let's take a look at some of the hole feature improvements in Inventor 2019. The hole tools had a lot of community feedback and attention in the beta testing forums for Inventor 2019, and it really shows. Autodesk have listened well, and the tool is now very capable and it's got some fantastic new features, such as saving hole presets, your favorites, so you can easily access your common hole specs, and also the ability to do more intelligent placement of holes flexibly rather than the previous 4 placement methods that you used to have to do. You used to have to decide whether you wanted to place holes by sketch points or concentrically to an edge, or just a linear placement of a hole based off two linear edges. And once you picked one of those methods, you had to stick with it, and it wasn't very flexible in that respect. Let me show you how it works now. We're not going to look at all the tools, all of the options in the whole tool, just two of the most important ones that I think have been introduced. If I start it, we're going to look at the placement, the new placement options, and also the presets for the new hole tool. So first off, placement. You see, I started the hole tool there, and the hole tool's automatically picked up 4 sketch points that were visible in a sketch in the model. But what if I want to add an additional hole? Maybe I forgot to add it in as a sketch point into my original sketch. Do I have to cancel the tool and do it again? Well, I don't. It's very flexible in this respect. I've got breadcrumbs up the top here, as they're called. I can click on this sketch here and go and directly edit the sketch that has been picked up for the holes. So if I start the point tool here, I'm in my normal sketch environment. See, I've got all my normal sketch tools here. I can dimension from whatever points I need here, put constraints in, same as usual. Sketch is fully constrained. How do I get back to the hole tool? I just click on hole here. So I can toggle back and forth between the hole and the sketch it references, which is fantastic. There's another way of doing this as well. I can actually add randomly positioned or specifically positioned extra holes in here without having to follow the breadcrumbs up here. Let me show you what I mean. If I just click somewhere else on this face, it's added a new point. Where's this point been placed? It's actually been placed in the sketch that the other holes are based off of. And then I can simply just add dimensions in here, the same as I would while not being actually in the sketch environment. Let me show you what I mean. It's asking me select a linear edge to dimension from. So if I pick this edge here, there's my dimension. What do I want that dimension to be? Well, I want it to be the same as this one. So how do I do that? Well, I can click on this one, and I think I have to select this geometry, and I can say, pick this one here and say reference dimension. And if I pick that, it says which feature do you want to reference off of, which is this feature here, and then I can pick and say, well, I want it to be the same as this dimension here. So I pick that, and that's set. Then I can pick another linear edge and say, okay, I want to dimension from this point here, for instance. Oh, excuse me, I need to go back and undo that one, so I can simply hit Control and unselect that one. That hole there, it's now asking me to select a linear edge for the previous hole. So if I pick, I might need to hover a bit. I need to make sure I pick an edge here rather than a point, otherwise it thinks I need a new hole. And how far do I want this positioned? Well, again, I can select this number, and I can say I want to maybe reference a dimension. If I want to, I can just type it in, and I want to, let's say, have this hole positioned this distance plus, so I'll choose that, which happens to be called D162, plus, I don't know, 100 millimeters, and that's now placed that hole 1000 plus 100, and you see I've got this extra point. And so now if I was to accept this hole, you'll see what we did there is we added these 2 extra holes, and both of them have been added as points into the sketch that controls that hole. So you see in this sketch here, it's added an additional hole, an additional point with those extra dimensions that I specified. So we've kind of gone back into the sketch without going back into the sketch, directly from the hole tool. Very powerful. The other new feature in the hole tool I want to cover is the ability to save hole presets. And I have to say, the process of creating and using these presets, it's so simple, it almost doesn't need me to explain it to you. Let's take a look at how it works. If I start the hole tool, here's my presets. It defaults to the last kind of hole type you placed. So if I just simply want to place a hole somewhere here and position it from these edges, I can do that, and the hole type that it's placed is an ISO clearance hole for a socket head of size M8. But let's just say I want a new type of hole. Let's place one of those and then let's say, okay, now we're going to define a new type of hole. So let's say again I want a clearance hole. This time I'll do a counterbore again, but this time I want a clearance to an M10 bolt, and I want a close fit here. Let's say I want it only of a certain distance as well. I don't want it to go all the way through. And the distance, the depth of the hole I want, say for instance, is let's say 45 millimeters. Okay, and I'll position it here. So there's my preview of the new hole that I've created. If I'm really frequently placing this kind of hole in parts, then this is where you want to hit create new preset here. And what it will do is it will give you a suggested name for the new preset, which is just basically a concatenation of all the properties that you've specified for this hole. You can see here the size of the hole. It actually doesn't include the depth in there by the looks of it. So if I wanted to edit that before accepting it, I could say, let's just say underscore depth, let's just say underscore 45 dp for depth. And when I'm happy with that preset name, I just hit this tick to accept it. It's now saved that preset. I haven't actually created the hole, but I can create the hole here. And then if I want to use that hole again, let's close the dialog just to show how this works. If I start the hole tool again, last used, if I click to place that, this is my 45mm deep one, or I can select any other previous favorite that I've created and simply just add that in. So it really is an extremely simple but powerful tool. Kudos to Autodesk. I think they've really hit the nail on the head with this new hole tool. Let's take a look at some of the new assembly constraint tools. I think the one that needs the most explanation is the new ability to flip the direction of an axis-to-axis mate constraint in an assembly. Let me show you what this means. So I'm going to hit place and just place in a T-joint into this assembly. I'm going to right click and rotate about the Z-axis to get it in roughly the right orientation. Then I'm going to start the constraint tool, and I'm going to do a mate, and I'm going to pick this axis and this axis here. Now, to give you an idea, I'm just going to say OK before we look at anything else here. Let's move this into the middle and let's go and examine this mate constraint we've placed. So I'm going to right click and say edit. And now here's our three new options. We can have it one direction or the other direction, and you see the direction of the actual mate there is flipped, or we can choose to have it undirected. What does this mean? Well, while these two will lock the direction of the axes to be aligned or opposed, this one will actually leave the direction free in order to be constrained by another constraint that we place afterwards. So let's leave that free by saying undirected. All we've done is put these two lines, the axes, on top of each other without determining a direction. And let's say OK, and we've left that free to constrain with, for instance, a mate or a flush constraint afterwards. So let's go and put another constraint in, and let's just tick this box to give us a bit more of an idea of how this is going to work. And I'm going to pick this face here and this face here to define an offset. Now I can do that with a mate constraint face to face, or I can do it with a flush constraint. And you see here I don't get an error with either option because I've left that direction free for the follow-on constraint. However, let's say we're happy with this one here. I've constrained that with an offset of, say, 36 millimeters. Let's say OK. Now if we were to go back into our original mate, which is the axis to axis mate, and if we were to say, no, actually we want to define a direction here rather than leaving it directionless, so to speak, then what we would do, one of these will work and one of them won't. So let's try this one here. Opposed works, but if we right click and edit that, aligned will not work because the aligned constraint that we're trying to put on here will conflict with the flush that we put on afterwards, because they're both trying to determine a different direction. Okay, so hopefully you can see that this gives you a lot of flexibility to either quickly place a constraint and define the direction, axis to axis, or leave it open for afterwards constraining with a mate constraint. Another new assembly constraint tool is the ability to lock an insert constraint. Now, any Inventor veterans will know that you've been able to lock rotational and cylindrical joints since Inventor 2014, and they're quite powerful because they let you lock the angle of the joint at a particular angle that you want. However, the insert constraint lockability is a bit different, so let me just show you something to be aware of with this. I'm going to start the constraint tool. I'm going to choose an insert constraint, and I'm going to just pick two circular edges here as normal. I can flip that as before, and I can choose to either lock or not lock the rotation of the joint. So let's just leave this unlocked for the moment and say OK, and now our insert is free to rotate as usual. I can go back into the joint at any time, either by finding it in the relationships folder or doing a free move and finding it like so, right click and edit, and I can lock it at any time if I wish. However, the position of the twist is not negotiable with this. It will lock it in one orientation and one orientation only. So if I say OK, I don't have the option to flip it 90 degrees or anything like that. Okay, and if I do lock the constraint, I get a handy different icon here for the locked insert. Here's a locked one, here's an unlocked one. It's just something to be careful of here though. Let me just edit this constraint and unlock it temporarily. There we are, and I want to put an angle on this T-joint here, so I'm going to add another constraint, an angle constraint between here, and I'm just going to make that, let's say, 30 degrees or minus 30 degrees. Okay, and that's all fine, but what happens if then I want to go in and lock this insert constraint afterwards? If I go and edit this and hit lock and say OK, Inventor's going to tell me there's a problem with that. Now this might surprise you. In this case we have two options. We can either accept the relationship and unlock the insert by right clicking, edit it and unlock this and say OK. We've got no error now. Or we can keep the insert locked if I hit undo, and we can delete the angle constraint, and the insert will then determine the twist of this component. So this gives us an idea of what this lock insert constraint is designed for. It's not designed to specify a particular rotational twist for a component going into a hole. It's actually designed just simply to stop stuff moving. So you wouldn't use it for components like this. You would use it for inserting multiple bolts in multiple holes, for instance. Those would always traditionally have been able to spin in the hole with an insert constraint, and you just simply lock all of those, which reduces some degrees of freedom and frees up some processing power, as Inventor doesn't have to compute these free to rotate bolts anymore. They're just fixed and grounded. So it's almost more of a performance enhancing tool, if anything else. Just one last thing to note with this lock insert constraint, you can't right click and unlock it here like you can with a rotational or cylindrical joint. Again, this gives us a clue as to the intention of this ability. It's not for editing really, it's lock it, lock and forget is the idea, I think. Let's take a look at the iLogic additions for Inventor 2019. iLogic's had a lot of attention from Autodesk in this release, particularly in the area of assembly management and configuration. So if you are producing configurations of your products, or if you've got any interest in automation in Inventor, there's some very powerful tools and also the option to drastically reduce the amount of code that you'll need. Now I'm going to show you some examples in a moment, but first let me just explain the reasoning behind these additions to the iLogic toolset very briefly. iLogic configurable assemblies have traditionally required you to assemble all the components you might want in the assembly, and then use iLogic to switch on the components that you do require and switch off the ones that you don't. So we've got a really simplified example here. We've got 4 components assembled into this assembly. We've got 3 possible configurations, A, B and C, and each one of these uses, let's just say, only 2 of the components, and the ones that we don't require are switched off or suppressed for each particular configuration. Now, of course, this isn't the only way to produce iLogic configurable assemblies. You can use component replace and things like that, but component replace has its own limitations in terms of preserving assembly constraints, and the two components you're replacing have to be very closely related to each other for the operation to be any kind of success. So to achieve this simple switching between components, how much iLogic code did we used to need? We used to need this much. In its long-winded sense, 4 lines of code for each option to switch on the components that we want and switch off the components that we don't want. And if we were to add a 5th component in here, what we would need to do is to edit our code, and instead of having a line for each component for each option, which is what we've got here, we would then need to have, well, same thing, a line for each component. We've now got 5 components for each option. Of course, there's ways around this, but I'm looking at the traditional method used by many companies to do their iLogic configurations. So this placing of all the possible components you'll need in the assembly method created traditionally a bit of a glass ceiling in iLogic in terms of how much flexibility you could feasibly build into your iLogic assemblies, because adding more options meant exponentially adding more and more controls in your iLogic form and exponentially more code for each extra component and option you add. And also, you had to use a custom level of detail in order to suppress the unwanted components, and that could lead to some frustrations also. Now let me show you how, using the 2019 methods, we can simply manage this assembly and add in the required components without needing to suppress the components that we don't want. So the first thing I'm going to do is, well, unsuppress all of these existing components in here. I'm going to add a 5th component just by copying and pasting. I might add a color override to one of these just so that I can see the difference in here. So we've got 5 components. Let me just rename this component comp5 as well, so it's got a clear name. Well, the name matches all the other ones. And I'm going to go into my iLogic rule and convert this to a shiny 2019 iLogic rule instead of the slightly cumbersome 2018 version that I had. So I'm going to go into options here. So the first thing we're going to do is to say that this is a managed assembly. So I'm going to go into here and say manage components. And let's get rid of all this slightly scary stuff in between the begin and end manage statements. And we're going to put in our options in here inside the manage statements. And then we want to say we want to only turn on the components that we actually want to turn on for option A, and don't worry about the ones we don't want. So I only want components 1, 2 and 5 here. So I'm going to select this, and I'm going to then select up in my file tree here 1, 2 and 5, and right click and say capture current state components add. It's added in a lot of information in here, but I don't need to worry about any of that. It's just captured the state of these components and said we basically need them. So for B, I'm going to say I only want component 1 and 4. So I'm going to select 1 and 4, right click, capture current state components add. It's capturing the fact that the component is required, but also the position of it, also the color overrides as well. We won't get into the details of this right now for this top level overview. For option C, if I hit undo, we want component 2 and 4 and 5 here. So I'm going to select 2, 4 and 5, right click, capture current state components add. And now if I hit save and run, we get some serious changes in here. Let's delete all these components and save the assembly, and this code is now going to run and only add the components that we actually need based on the option we select. So I'm going to bring up my iLogic form, and if I choose option A, it will add in the 3 components that I need for option A, 1, 2 and 5. Option B is 1 and 4. Option C is 4, 2 and 5. They've been added in the right locations as they were when I captured their state, also with the color override that I put on one of the other components when I created the original iLogic code. And you notice here there's no suppressed components, there's no need for a custom level of detail. It's simply just recorded the state of these components when I created that rule, and if I choose the right option, the manage statement actually just adds the ones I need into the assembly, and even more importantly perhaps, deletes the ones that I don't need for me without me having to worry about it. So hopefully you can see this new addition, just the one that we've looked at just now, is a real game changer for iLogic users. Hopefully you can begin to see the possibilities. I want to show you a few more examples now. Let's just go into our iLogic rule here. There's a lot of new iLogic functions in here, particularly with iLogic assemblies and components, the positioning of components, relationships and constraints. Many of these new functions also have several options included in them as well, which can really make it quite confusing when you're starting out with Inventor 2019 to see how to actually apply all these new powerful tools. So to help with this, I thought I'd take the time now to simply demonstrate 4 or 5 new types or styles of iLogic configurators that have been made possible in this 2019 release. So I'm going to be calling them a recorded configurator, a modular configurator, an adaptive configurator, and a computational configurator. And when I show you these, I'm going to ask to rely on your imagination a little bit to apply these possibilities to your particular industry and your products. These aren't the only new possibilities for configurator style by any means, but perhaps your products will lend themselves to 1 or 2 of the examples I'll show you. And also from now on, as this is a relatively high level presentation, we won't be looking in great detail at too much of the code itself except a few key areas.